All right, today we are diving deep into one of the most important ideas in the entire blockchain world, proof of stake. Seriously, this technology is changing everything, so let's get right into what makes it such a big deal. So here's the big question, right? How do you keep a massive global network secure without, using the same amount of electricity as a small country? For the longest time, the main way to do this, proof of work, meant having computers solve these incredibly hard puzzles, and that used a staggering amount of power. So people started thinking there has to be a better way. And this slide just nails the difference. Proof of work is basically a contest. It asks who has the biggest, baddest computers. The most raw computational power wins. But proof of stake, it flips the script entirely. It asks a totally different question. Who has the most skin in the game? In other words, who's the most financially invested in seeing this network succeed? It's a huge shift from processing power to economic power. Okay, so here's our game plan. We'll start with that power problem that got this whole thing started. Then we'll dig into the staking solution itself. After that, we'll talk about the key players, the validators, and then get into the really cool part, how the system uses pure economics to keep itself safe. And finally, we'll look at what's next. So let's jump right in, the staking solution. This is all about that huge pivot we mentioned, moving away from who can compute the fastest to who has the most capital invested in the system. So what is proof of stake, really? Well, at its core, it's a system where instead of mining, people lock up their own coins as collateral. This is what we call staking. The network then uses an algorithm to pick who gets to create the next block of transactions, and you guessed it, the more coins you have staked, the higher your chance of getting picked. And honestly, this is a total game changer. It means you don't need a giant warehouse full of super expensive, power-guzzling machines anymore. All you really need is to own the currency of the network. This opens the door for way more people to participate, seriously lowering the barrier to entry. Okay, so if there aren't any miners, who's actually doing the work? Who's securing the network? Well, that brings us to the key players in any proof-of-stake system, the validators. You can basically think of a validator as the proof-of-stake version of a miner. These are the people who put their own coins on the line. They stake them for a chance to be selected. If they're chosen, their job is to check transactions, bundle them up into a new block, and add it to the chain. And for doing that job right, they get paid rewards. So the whole process really breaks down into three main steps. First, you stake your coins, locking them up as collateral. Simple enough? Second, you wait to get selected. The network's algorithm chooses who gets to make the next block. And while a bigger stake helps your odds, most systems have some randomness built in to keep things fair. And finally, if you're picked, you forge the new block. That's just the term for creating and adding it, and boom, you get your reward. Now, that all makes sense, but it leads to the biggest question of all, doesn't it? How do you keep everybody honest? And this is where we get to the most brilliant part of proof of stake, security through economics. The whole thing is designed so that it's just way more profitable to be a good guy than a bad guy. And this is the absolute key. Validators have their own money locked up in the system. So think about it. If you tried to attack the network or approve some phony transactions, people would lose faith, the coin's price would crash, and you'd be destroying the value of your own investment. Your financial incentive is to keep the network healthy. But what if an attacker doesn't care? What if they just want to cause chaos? Well, that's where this really powerful tool called slashing comes in. If the rewards are the carrot, slashing is the big, heavy stick. If a validator gets caught trying to cheat the system, the network can automatically punish them by taking away, or slashing, some or even all of their staked coins, for good. Honestly, the best way to wrap your head around this is to think of it like a security deposit for an apartment. As you can see here, if you follow the rules and play nice, you get your deposit back at the end, plus some nice rewards. But if you try to break things or cheat the system, you lose that deposit. It's a really simple and powerful way to make people think twice. All right, so we've covered the mechanics and the security model. Now, for our last section, let's zoom out. How is proof of stake actually being used out there in the wild, and what kind of challenges is it still facing? Yeah, this isn't just a theory anymore. Some of the biggest names in the space are running on it. Ethereum, the second biggest crypto network out there, made that famous, massive switch from proof of work to proof of stake to cut its energy use by over 99% and improve its scalability. And other huge platforms, like Cardano, were built on proof of stake right from the get-go. And the innovation just keeps going. One really popular version you'll see is Delegated Proof of Stake, or DPoS. With this model, instead of everyone trying to be a validator themselves, all the coin holders just vote for a small group of delegates to do the validating work for them. The idea is that this can make the network even faster and more efficient. Of course, no system is perfect. One of the classic criticisms you'll hear is something called the nothing at stake problem. The fear was that, in theory, a validator could support multiple versions of the blockchain at the same time at no extra cost to them, which could create a lot of confusion and instability. But modern proof-of-stake systems were designed with this in mind. Those same slashing rules we talked about are built to punish exactly this kind of behavior, making it a very, very bad idea. And that brings us to our final and most important question. Proof of stake is a brilliant solution to the energy problem. It replaces computational power with economic power, but it leaves us with this thought. When you tie the security of a network directly to wealth where the richest players have the most influence, do you end up creating a whole new set of challenges for that big dream of decentralization? That's the conversation the whole space is having right now. Thanks for tuning in.